let me put up the screen. And if you haven't joined our Discord, Telegram, please take a minute to join. We also want to introduce AllERCDevs. I think AllERCDevs take a lot of inspiration from other regular meetings in this space. AllERCDevs for sure, and also WalletDev run by Sam Wilson. Basically, the idea is that we want to bring all ERC builders, authors, and adopters to form this Ethereum's IETF, where everyone can discuss proposed standards and then other people can give input. Because silo building is not fun and also very unproductive. And the only way we see the way out and for this entire group to become, for this entire community and ecosystem to become open, is to have a way to work and collaborate openly. And that means people can come to agreement, people can build towards the consensus. And so every time AllERCDevs will run about an hour, and usually each topic is about 10 minutes plus 5 minutes Q&A. We sometimes collate relevant topic together. For example, I think 6066 and 1271 is very relevant. It involves signing. And sometimes we talk about governance because people care about governance. We also feel that it is important for us to just meet and know each other. The meeting, by the way, is recorded and being published, and we hope that we will also publish the notes. So for whoever is on the call, thank you for being here. We have Jack here, we have Vexrise here, who is going to be presenting. And Redak, thank you for being here. If you want to introduce yourself a little bit, that would be great. Maybe I'll recognize your GitHub handle more easily than the name, like that's the nature. But I'm Victor, I'm one of the IP editor, and I kind of drive this meeting. Thank you for being here today.
Yeah, well, thank you for inviting me. I saw your invitation on, I think it was the ERC20 ERC, where it was mentioned like a month ago or a couple of weeks ago. And I later realized that this is the platform which was like missing or has been missing for the standardization. So I am eager to to use this platform basically to discuss a couple of things which we are like cooking or drafting on our regular monthly developers meetup, where several potential ERCs are in the preparations and even potential some EIPs. So I wanted to first to see, how it proceeds here and whether it would be like fit to the purpose and towards the overall like process, I would say. So just to correct yourself, I will not be presenting today, but since I do have there like the recent EIP listed on the GitHub. And we do have a plans to list, or ERC, sorry, and we do have a plans to list some more, even in EIP. I would be rather than aligning with you or with someone for the further agendas in the upcoming sessions like this. And yeah, you asked me for a little bit of intro of myself. I've been, let's say, in the finance industry for over 20 years. I've been, on the other side, previously, like more than 18 years in the traditional finance, in the banking, in the IT management of some of the banks. But I've been like several years
think you can,
in crypto.
Yeah, Redak, I think one easy way to introduce yourself is either like you're proposing which ERC or you're, yeah.
It's actually both. In my case, it's both. It's both proposing and also adopting several of the standards into the solutions which we are having over here. Mainly those which are related to ERC20, where I'm let's say the designer and architect of the local stablecoin which we have in the preparation. So that's one of the triggers to actually work with that. Yeah.
Look forward to it. Cool. Alrighty. Thank you, Radak. Welcome to the group, and then look forward to more contributions. And of course, I want to see your proposal, and then we look forward to hear them in this meeting as well. With that, I think we have waited enough time, and we should get started. We have Jack, who is the author of Signature Validation Through a Method for NFT. So Jack, if you want to present, you can present. You can verbally introduce that too. I can pull it up. So however you want to proceed with this. And usually it runs by 10 minutes, and then we can have 5 minutes for discussion afterwards.
Yeah, I have a slide deck, but I think it makes more sense if 1271 is talked about first.
Oh, okay. If you want to let Vectorize talk about 12.71, that'll be okay. Like Vectorize, how do you want to proceed with it? Do you want to like show first?
Cool. I can present
of course.
first. This is a. Okay, let me try to share my screen. Okay, hold on. Okay. Are you seeing this?
Yeah, I can see your screen now.
Okay, that's good. So, okay, basically is how you can use this ERC1271 and ERC712 for smart account so that they can sign signatures. Okay, so the background is last year, certain month, some person called Curious Apple, he's a security researcher, he found this vulnerability that if an EOA owns 2 or more smart accounts, the same signature can be replayed across these smart accounts. If the digest does not incorporate the address of the smart account that is supposed to verify the signature. So he wrote a Medium article and he go and discuss the whole thing. And basically this is 2 parties are at fault. One is the external applications, the other is the wallet. So the external applications should hash the signer into the digest, but most of them don't. Wallets should also hash the hash before it's validated, but only some of them do, and there's also a problem about that. So the problem is that where's my thing? Okay.
Can you also share the link? I think that link is very helpful.
Okay. Copy link. Where's the chat? My God, I can't find the chat.
I think it's in the people, like the 9 people. Okay. Yeah, that's the chat. Okay. Yes.
No, sorry. I copied the wrong link. It's my bad. Okay, this link. Yeah, the mirror.xyz thingy. Okay, so he describes the whole thing, blah blah blah. And then initially we came me, Frangio, and I think Juno from Chainlight, we came up with an initial idea on how we can hash the stuff in the valid signature while still preserving EIP 712 readability. So what do I mean by this?
Let me clarify this. The problem is that smart contract people were copying the reference implementation right from the 12.71. Didn't realize that implementation was just for demonstrating purpose, and there not enough replay attack prevention in it. Now, the constraint is the existing deployed smart contract cannot easily be swapped out. So they have to figure out a way to make hash differently. That's like one of the solutions to solve this replay attack risk by changing what to hash, right?
Yes. Okay, but there's also a limitation. Let's say if we hash it. So if you see they hash it, but after you hash, this hash is opaque. So what this means is that if you are somehow in the ideal world, if we can use MetaMask to control our smart accounts with our EOA, the EIP 712 pop-up won't show the hash. So it might look something like this. So Howie from Alchemy wrote a thread on this issue. I copy and paste the link here. Okay. So initially we did something, and then okay, so the most simplest implementation will just display an opaque hash, although this hash is replay safe. So the first iteration we try to do some stuff, but then okay, in the happy scenario it looks good, but it might be open to phishing attack vectors. Like because in order to display this 712 signature request, we have to append some stuff at the end of the signature so that the smart account knows how to wrap the signature in a way that can also correspond to this 712 request. And that opens up a phishing vector. So for example, this is a thing that looks like a legit signature, but you are not able to see that it's actually maybe an approval for USDC. I think that is a meme coin approval. So after even more iteration, the ideal way is that you can control the whole stack. Let's say you're Coinbase, you own the Coinbase wallet plugin, you own the Coinbase account implementation. Yeah, you can control the whole stack, but often we don't own the whole thing. So the other approach is try to fix it as much as possible in a vendor agnostic way. So the Solidity part is Solidity ERC1271, and someone called Arpov, he also built a browser plugin to try to use it. So the idea is instead of waiting for wallet clients to update, we try to make it as complete on the Solidity side and also allow like permissionless building via browser plugins. Okay, so how Solidity 1271 work? Okay, never mind. Later I will go to the code. So the idea is that we're going to append some stuff at the end of the signature. So this is the regular ECDSA signature, 64 or 65 bytes, depending on whether you want to use the compact format. Then we have to append the domain separator of the calling contract, which is whatever contract that calls the smart account. And then we have to append the hash struct. That means the hash before is hash into this signature, into this digest. And then we have to append the encoded type of the contents, and then we have to append the length of the contents. So without going too much into it, this voodoo magic is such that
Voodoo
the
magic.
EIP 712 still can show up, and also we somehow constrain it such that even if someone wants to do some phishing attack, the signature will look very suspicious. Like they will have all these weird control characters in the variable names. So it's not phishing proof, but phishing resistance. So what it means is that someone can try to like inject all these weird characters into the name to trick the MetaMask to sign it, but it will look suspicious. So the ultimate foolproof water type way is that all of the JavaScript code is updated such that they throw an error if the name has this kind of weird characters, control characters. But most of them, actually all of them right now, they don't implement this simple validation because EIP 712 is kind of under constraint. So they just do the same the naive way of just concatenate all the names. And in the SQL world, there's SQL injection. So this is kind of like EIP 712 injection. Yeah, so the end goal is that any smart wallet like MetaMask can control any smart account. We don't need to wait like for the front ends to update their JavaScript. We also don't need to wait for wallet clients to update. So,
so it will be how does that work? Is that going to be there will be a deployment of Solati's ERC 721 implementation, and if you sign something, you will use the hashing. You will use the hash structure provided by what Solati is doing, and then relay that to call the other smart contract. Is that how it works?
Okay. Okay, I show you the slow daily code. It's very disgusting because it's like entirely in assembly, but I wrote a lot of comments, so hopefully it's still readable. Okay, yeah, it's here. Okay, so this is the whole bunch of comments. The comment is more than the code. Okay, so the idea is, okay, never mind. I go back to the comments. So there are two workflows. One is type data sign, and one is personal sign. For personal sign, the signature is just as it is, but you have to wrap it in a certain way that will force MetaMask to expose the string that you're signing using personal sign. Okay, but the more complicated workflow is the type data sign. So in order to force MetaMask to show up the 712 correctly, we have to pass in the knowledge of what this 712 contains at the end of the signature. And we also have to create the digest in this format. And this format is specifically chosen such that it's phishing resistant. Like contents is enforced to be a struct. Because
this is actually extending. This is actually just extending the EIP 712 domain.
Yes.
Right?
Yes.
You're adding extension, right? The real change that you're proposing here is what to put in that extension, right?
It's not really an extension. Like the extension, it will still be it was just so normally the extension will still be an empty array, but this is a way we force people to sign in a way that MetaMask can show the 712 correctly.
Because this is the way how you propose here is the type data sign, which exactly is 712, right? It's the way how 712 is hashing and signing. It dictates the hashing and signing.
Yes. Okay. So the thing about 712 is the standard looks complicated enough already, but surprisingly it's still underdefined. Like they don't actually define how extensions are supposed to be defined. So this is our best effort at trying to make something that is phishing resistant and also usable today.
Yeah.
Yeah.
Cool.
So the next part is like how do we somehow formalize into a standard? And why is that good is because if somehow this becomes a standard, then JavaScript libraries will know, okay, how to wrap this digest in this way, and then wallets will also know, okay, what we can expect. Like we have to check whether the name have any control characters, and then reject the signature.
I agree 100% that we should standardize this. But before going down, how much more that you architecturize do you want to talk about, or do you think that we can open up for a discussion?
Okay, yeah, please open up discussion. I think I over.
Yeah. Yeah, this is great. Actually, I think this is great. I wanna like I have a few comments on this. I think there's a way towards standardizing it, and then I think this is very valuable. We should actually let people know that you should you should be very cautious in how your 12.7.1 contract compliant contracts deal with the hashing, and it should be a structure. It should be typed. I want to open up the floor first because we happen to have Francisco in the call, who is the author of 12.7.1. So Francisco, of course, I know you were also in that firefighting Telegram group where people discovered that they were just using the reference implementation you shared directly. So yeah, do you want to comment? Do you want to like give any suggestions here?
Yes. First of all, I was co-author. There's always a lot of other people to
Yes.
consider. But so yeah, no, I do have a question because I'm not sure. First of all, is there a reference implementation that is not using assembly? Because I think that would be very valuable.
Okay, I can write it.
That would be very cool.
I
And the other one is
I have something that is not assembly too in 5.4, 5.3, which I will bring up later. Yes, there's a way to do it
Okay,
without assembly.
I will write it for the sake of adoption.
Yeah, totally. I mean, yeah. And the other is, so at some point in the pull request, I suggested to put all of the domain fields kind of nested in an object. But I'm guessing that you flattened it because otherwise it complicates the construction of the type hash. Is that correct?
Yes, correct. Because let's say if there are two structs, then the structs have to be sorted by their name in lexicographical order, which is like, it's super disgusting to do in Solidity.
Nice. So in this way, it's just as simple as passing in the context type string inside the signature.
Yes, correct.
Nice. Do you know how large the signature ends up being for like common types?
Okay, I think this will be estimated around 200 bytes.
Okay. You know, it might be interesting to like have a way to compress that. But just like having common types that the contract supports. You know, so like a permit 2 could be encoded as a enum that says, oh, this is a permit 2 signature. Maybe that could be interesting. What do you think?
Here's what I would like to like bring to the attention. I think 7.1.2, of course, it's a very unfortunate situation in how it was edited. And I can share a little bit more about that, but I think 7.1.2 is put in a way that it allows signature to be structured, hash structure to be provided. So I want to also like show this was the original intention of 7.1.2, and then because it's extendable, we can also extend it. You are supposed to just sign whatever is hashed, the structure hashed in 7.1.2 with domain separator, and the content. I think the content is somewhere here. Yeah. So you're supposed to be able to sign in the structure, and let me see how to deal with. Yeah, there is a content structure, and then there is a domainer. There is a domain that you sign together. It's already defined in EIP 7.1.2. Now, vectorized, I think what you want to solve is that user getting hidden from what they're signing about, and you want to provide that information. And I think one way to do it is to preserve the signature still being 65 characters, which is not going to be easily changed. But I think someone is creating, of course, Francisco creating how you retrieve the domain so that web apps application could this line actually. Yeah, if you take a look, this line enable a DApp to retrieve what is being inside of the EIP domain. And there's someone else who also wrote on-chain visualization, which I think is still a draft, I guess. Yeah. But basically you can say, hey, can you give me what you are signing, right? Not just the hash result. Can you give us the original version of the data so we can also see what's being provided? So that would be my thought. But yeah, I think once Jack
What's this EIP?
present. Oh yeah, let me put these two inside. So this is one that is visualization, which is, I guess, make it readable. I think that would be a better name. And 712 retrieval of EIP domains. A lot of people ask me what's the most undervalued EIP. I like to say 1271 and 712 because they are the foundation of smart contract wallets. Another aspect I think we should work together to advocate this is the extension should include what is being signed, not just like here's a CAN ID, here's a contract that I'm validating it, but also additional information. For example, in Jack's ERC that he's going to share later, which would be if there's a bank using each NFT to represent an account, and then that NFT can hold assets, you should be able to sign against that NFT ID. On the other hand, I think we have a similar thought here in the endorsement that I propose, where we actually let users sign endorsement for what they are trying to, what function and what variable, what parameter they are trying to execute. So in your design, in your proposal, you also say, hey, I didn't just mean that I'm validating against this contract. I'm actually I'm specifically approving that I'm transferring this token of USDC to that account through my smart contract. So that the more specific we are about user intention of what user signs, the less likely it's going to be reused or replayed, attacked in a different place. Yeah, so that would be my feedback to this. And then of course that's also related to the ERC EIP 307 for there's a commit concept, which is I think similar. Like you want to let user be very specific in what they are trying to sign and approve.
Yeah.
I think this is important, and thank you for initiating this and leading this, Vectorize. I think we should have, maybe at some point we should have a breakout room with you, with Francisco in the room, maybe with a few other people who care about this in the room to discuss how can we improve it as a standard.
I think the main problem right now is I don't know whether it's completely foolproof and safe. So we have tried our best such that it's phishing resistant as much as possible, but we don't know whether it is good enough.
That's true.
Yeah.
Yeah, that's true.
So
but thank you. I think this is super important.
Yes.
I have a short question, scope-wise. Is this relevant towards the implementation of the contract which is calling the is-valid signature as well? Example, Circus USDC upgraded their contract to include the 1271 into the validation of the permit. So does this issue impacts also these contracts?
Okay.
I think if all of the contract that implement ERC 1271 update to ensure that what they approve for the hash structure, if they require this hash structure to be replay, attack, or prevented, then we have no problem. The problem is that there are many smart contracts that already implement is valid in a way that didn't specify a replay attack. But yeah, Vectorize, sorry, go ahead.
Oh, okay. So this 1271 is supposed to be agnostic to how the contract that is calling it will check for the signature. Yeah, but if we know that a certain contract has done the digest computation in the safe way, like for example, that one of my code called multi-caller with signer actually hashes the account into the digest, then I can like put it into the white disk, into the bytecode, and then skip the entire need for the nested EIP 712.
Mhm. Well, from my understanding, in this situation which I mentioned, the contract calling the is-valid signature is in fact like pass through whatever it comes there from the wallet,
Yes, correct.
which are impacted, and then there is a smart account which is then doing the stuff with the hash which is or the signature which is passed. So
Yes,
my
correct.
assumption is that these implementation of the contract which is calling the is-valid signature, that these are not impacted. That's
Yeah, it's not impacted.
yeah. Thank you.
Cool. Anything else, Vectorize, or anyone else want
No,
to
I
comment
got
on this
nothing
before
else.
moving?
I
Yeah.
actually want to
Vectorize,
ask
let
one
me
final thing, but I can leave it for
Go
the
ahead.
end so other people have time.
Oh yeah, that would be great. Yeah, actually, that would be great. Yeah, so let's make sure that Jack has the time to present, and then we can like put them in one context to discuss this. So Jack, do you want to proceed?
Yeah, let's go.
Yeah. Okay. The floor is yours.
Yeah, perfect. So I made a quick presentation here regarding the ERC that I wrote. So it's called Signature Validation Method for NFTs. So as Victor alluded to earlier, this ERC specifically enables NFTs to carry signatures that they made. So I guess one small issue that I had with 1271, despite despite the subtitle being a standard way to verify signature when the account is a smart contract, I think the problem is, well, it may not be a problem, or it could be the way that people or I'm interpreting it, because the 1271 contract, if we can look at the function signature here, it takes in a hash and also a signature. So in this case, I think at least my first reaction, and I believe I'm not the only person to have this reaction, is that okay, well, this is basically a pass through of EC recover, because like you can easily just take in an EOA signature, EOA hash, and then if this is a view function, so obviously you can't really have message at sender, but if it's called within the context of another non-view function, you have message at sender, and now it's basically a pass through for EC recover. That was like my first reaction, and I know maybe that's not the intention, but I think the problem, or a point of confusion is that the way that this is presented, it allows EOA signatures to be verified. So like if an EOA signature somehow passed into another non-view function, and a non-view function calls this function, and in this function, the way to implement it, if they use like message at sender or something, then it will return true for an EOA signature, and that signature has absolutely nothing to do with the smart contract itself. Right. So I think that's like a potential point of confusion, and also as you guys said, a lot of people, especially I kind of I also kept this in mind when I was writing the reference implementation, is that like a lot of people they'll just copy the reference implementation, but really the reference implementation for 1271, it's just a demo of how actually let me check exactly what it is. Yeah, so for the reference implementation for 1271, I can pull it up here. It basically just checks if it just tries to do a recover signer on the hash signature, and also if it's equal to the owner that's stored within the contract, right? Which is a problem now, I think, because and this is also a little bit that I think that needed clarification, which is because in the title it says when the way to verify signature when the account is a smart contract. And I was guessing that what it was trying to say is that if the signing party is a smart contract, but right now in the reference implementation, the signing party is actually an EOA, and the smart contract, and this is just like a recover signer, which is like a EC recover pass through. So I think that was quite a bit. I think that could have like misled some people to into having the wrong implementation. And I also think that, I think that like having pass-throughs is okay, but I think there is value where you enforce a non-pass-through signature, because smart contracts can't really sign. For example, in like the Gnosis safe implementation, the signature is really just like a mapping that maps from like a byte32 to a Boolean, right? Like it's just that the smart contract approves of the hash or not, basically, right? So the term signature is a bit loosely defined here because, or we can just say it's consent, right? And not just like signature. So what my ERC tries to do is that so first, like it semantically discourages and disables the use of EC recover or the pass-through by removing the bytes memory signature parameter to begin with. And then what I do is I try to adapt this to an NFT specific use case, and there are quite a lot of interesting use cases where it takes in a token ID, a hash, and also any bytes data. So that's like for future extension. Now you can make the argument that, well, okay, people can just use the line 11, the data field, to pass in the signature, and this will just be another pass through. Yes, you can do that. But this is not like this is. I think the intention of the author is a little bit more clear here. I mean, you can repurpose things all you want. I mean, you can pass in some other stuff and cast it to UNT56 and convert it back or something, but that's not the intended way of this thing being implemented, right? So I think the intention here, I'm trying to make it a little bit more clear that this is not intended to be a pass through. This is intended to only validate consent that's explicitly made by the NFT itself, not some EOA. So the standard itself, it's very, very straightforward. Technically, it's almost trivial, right? But I think it enables quite a lot of interesting use cases here. So the first one in ENS subdomains. So for example, right now, I think the way that things work, let's say I do run a startup, but let's say for every single person in my startup, I assign them an ENS subdomain based on their occupation or based on their how do you say it? Like whatever post that they hold, like whatever their role is, right? So for example, we have like an operations manager, we have let's say like the CFO or something. So let's say our operations manager, if they try to digitally sign some agreement with some other project, let's say we're trying to do like a collaboration or token swap or whatever it is, right? And right now the only way to do it is the only way to sign this with the operations manager's identity is to either use his private key to sign it, which is problematic because I have no control over his private key, but he's signing something for corporate use, more or less, right? And if you work in any like medium to large size company, that you use a company email, or even smaller companies use a company email, maybe sometimes company laptops. They have control over all of your assets, all of your work assets, because they technically belong to the company. But right now, there's no way for that operations manager to sign something in an official capacity, because he will still, even if he shares a private key with me, he will still own that private key. Like, I can't just make him forget, right? And of course, he can do it through like a safe, but that's such a huge overhead. And plus, people don't just use saves as like, I mean, some people do use it as like their multi-sig to secure their own funds, but like on a corporate scale, on the startup scale, on a startup's business scale, it's not very practical to set up a safe for everyone just to act as their work identity and have like a multi-sig for me to be able to kick them out and stuff like that. It's way too much overhead. So if ENS ever gets around to implementing 6066, it'll be very simple. I can give the operations manager a subdomain, let's say operations.esign.eth. And then what I can do is that he can then sign whatever stuff he needs to sign with this ENS subdomain. And then whenever let's say I fire him or something, right, I can take back that NFT. But then the signatures that he wrote, that the signatures that the ex operations manager made in the capacity of being the operations manager will stay with the subdomain that represents the office of the operations manager in my company. So it doesn't go with him, it stays with me, right? So I think that's one really cool use case. The second one is I'm plugging Victor's startup here, but so NFT domain signatures, right? So a little bit background if you don't know what Victor's doing. He's basically tokenizing domains by running like it's basically a GoDaddy, but then once he takes custody of the domains, he will convert it into an NFT, tokenize it so you can trade it and do whatever things with it. And one really cool thing to add to that is, if Victor implements 6066 with its domains, then now you can suddenly, you can sign stuff, you can consent to stuff with your domain, right? Digitally signed by like victor.com or something. And then when that domain is transferred to someone else for whatever reason, right? Maybe the old IT guy got fired or something. I don't know. Maybe I got fired. And so the new owner will still retain all the old kind of signing records because it stays with the NFT itself, right? And also basically any NFT-based consent where you use the NFT itself as the identity, not the owner behind it. I think this is very useful in that case. So that was a short presentation. It was nothing too complicated, too critical, nothing people shitting their pants because they copied the reference implementation. But I think this is more of an application minded use case, I guess, because I think it's just useful and it'll be cool to have it standardized, which it did get standardized, thanks to Victor. So I think right now we can have some discussion about this.
Yeah, thank you, Jeff. It's very interesting to see that ERC 6066 is actually built on top of 721, 1271, and 712, and also extendability, which is another ERC. It's like showing the power of composability. I think the use case that I really liked is the capability in an organization to sign in capacity. Let's say there's always going to be a president or a CEO of that company, right? Like you can be the CEO and CTO maybe, and then next time you can like step down and become a chair of board of director, and you shouldn't be able to sign to hire or fire someone without the CEO actually signing it. So like just like you said, I think having like ELAs or general smart contract accounts that sign in certain capacity in an organization is a great use case. I do have a slight difference with you. And then, of course, as author, you make that decision, is about including or not including the signature line. I think it's ECDSA recover for the signature, given the hash structure, is still a very powerful way. Like with that, you can enable both EOA and non-EOAs to call this function. And yeah, but I'll open up the floor. We have William here, we have Francisco here, and of course, Bertrand here. Any comments? And I think we can also combine these two because I think these two topics are very relevant.
Yeah, just to address what Victor said, I think I very intentionally removed the signature line to not let EOAs do anything because I wanted to be exclusive to NFT, because in this case, the NFT is the primary identity, not the EOA. So that's just like a decision I made.
Did you consider an alternative where this was external to the token contract?
All right. Well, the intention and the reference information that I had was like it's internal to it, but I can see that being external to the contracts is very useful when we're trying to retrofit older NFT contracts with this new capability. Yeah. So it's a good suggestion that I can think about.
I feel like
I wanted to ask
other comment.
Go ahead, William.
So I wanted to hook on, you're saying that the NFT owns the thing, not the person. So I was trying to understand that. Like, for me, the obvious solution is just to compose every NFT has an owner. That's basically the only thing NFT does. And then there are plenty of ways for an owner to sign a thing. So that makes a lot of sense. I mean, if you want to know if the person who owns the NFT agrees to a thing, then they're going to sign something. If we're talking about NameFi, right? The NFT does not do anything. People do things. These are servers. So there's already an element of centralization involved, or a trusted party. The trusted party is the person who's running a server, the third-party service. So I don't see why NameFi would ever use something like this, because there's like the examples you gave where you're going to fire the IT person. You're going to do something. In all situations, we're going to be signing something. There's going to be a signature outside of DNS. Maybe we're going to sign a PDF file. That is something we really need. We really need to sign PDF files that are verifiable back to a domain name. Right now, we can barely sign emails that are verifiable back to a domain name. That's why you can't email something to the blockchain. You should be able to verify an email on the blockchain. You can't do that right now. Those systems are not linked. But for many use cases, there's a person signing this. I really don't understand why, if I own two different pictures of cats, why I care which one of the cats signed the message. I guess that's the use case we're working on.
Yeah, so I guess cats are, so PFPs are not a good use case unless, so I think this is more about signing in what capacity. So do you want to sign in Cat A's capacity or Cat B's capacity? But like PFPs fundamentally, like they don't really represent identity. They represent an extension of the owner's identity, I guess. But something like ENS subdomains, or maybe like just NameFi domains, I think, instead of signing in the capacity of some current owner, I think signing in the capacity of the official, with the official domain, it's like a company seal instead of your personal signature almost.
Yeah, I can give an example, William. Let's say a Stockware is already giving out like Stockware subdomains, right? Let's say this role of Stockware controls certain threshold of Stockware treasury, right? Like if you were the CEO, you can make all decisions. You can also delegate your signing power to, let's say, assistant or a delegate manager who can sign above certain threshold. But basically, when you sign, you have an EOA or smart contract calling the main treasury contract to say, now move this USDC, let's say 10,000 USDC to the other, transfer to the other account. I'm signing on behalf of in my capacity as a CEO. So the NFT ID will be the hash of this whole domain, or let's say if there's specific domain, a specific NFT representing the CEO, and that ID will be called, that validation will be run against that ID who currently owns it. And there will be a public track record of, okay, at that particular moment, this approval is done to this EOA in their capacity as the CEO of that company. And of course, in the future, they will change CEO. Then even though you still control your EOA, you will not be able to sign on that capacity. And so right now, the problem is that most of the signing is in the capacity of EOA themselves, right? There's no clear boundary between who you are and what you are signing on behalf of. And I think with the NFT capability to sign, that's like an improvement. But yeah, I can see other way to do it as well.
I don't know. It's already, you can already compose that. So if we look at the history of ERC 721, one of the very hotly debated topics, which everybody takes for granted now, is the transfer from function requires you to specify which token is being moved. So in order to transfer a token, you need to say who is sorry, it needs to specify who owns it, what the token is, who owns it now, who's it going to. Those three things are required. And many people might think, well, isn't that redundant? Because if you know the token, you already know who owns it. So you really just need to say which token and where it goes. There's a lot of reasons why that's a security problem. And so best practice is that we have to specify the owner. Specifically, this prevents front running and marketplaces and transfer back, retransfer. There's some details we're not going to get into. But this exact use case works for what Victor's saying. If you want to know that the CEO in their capacity as CEO has signed something, all you do is say, here's the token ID, here's the person who's going to be signing on their behalf, and then here's their signature. And that composes with all the signature verifications we have today.
That's what you said. The three things is inside of the ERC 6066, and that's the whole purpose. It's specifying the token ID. Like it's not in creating a new ERC 721. It's using the same ERC 721 to specify in what capacity I'm signing on behalf of, right? It can be an NFT, like that is a paper, that is a CAD, that's fine. But we in here, like here in this situation, it's more likely to be a position, right? So, yeah.
Yeah, this is more niche than many many times there's just a party. You have this NFT, you go to this party. Party could be airdrop, party could be physically a party where there's people and alcohol. But we're talking about DAOs. Maybe there's something for this. And also these DAOs, they have to be on-chain DAOs.
Is a use case.
Because we're not doing anything that has to be verified off-chain. Like this cannot be for protocol upgrades or anything that involves humans, because there's no proof being put on chain here. That's just a function. It's a view function.
There's a view that's being put on chain as a log rather than like the state change. Be given as a view. You can also send to another function which calls this is valid signature, come back and change the state. So there could be.
I didn't specify like how you would actually like store the proof of when something is signed, because that would be a bit too restrictive. So I only tried to standardize how do you verify it. But in my reference implementation, there's like a very, very primitive example of like how to like store proof of what it's signed. But it's really just like, it's very simple. It's just like a mapping or something. But that's totally up to the person who implements this.
Cool. I think we still have like 3 minutes. I know that Francisco has another question he wants to ask. Right. Francisco, do you want to surface?
I was just trying to like understand what is the key difference with 1271, because the part about signature versus data, that doesn't really convince me as a key difference, just because in 1271 you can put whatever you want in there. You don't even need to use EC recover, right? Like you could use any other signature mechanism or whatever. And I was thinking if you could, like, as an alternative, use 1271 directly and encode the token ID. So, okay, because what I think is the main difference is that it's kind of like an is-valid signature indexed by token ID. So it's just the same thing, but with an additional parameter. And you could maybe encode that as part of the 1271 signature and use the same EIP. You're just adding the parameter in the signature. And it's using kind of a similar trick as what Vectorize presented, where you're just adding parameters into the signature, and you take that into account to implement the verification procedure. So I feel like that would be. Do you think that would be enough to implement all of the functionality?
I think, I mean, for sure. I mean, because it's byte memory, you can encode, whatever you want into it, and then decode ABI.decode in the actual function. But I think like, people already get confused just copying the reference implementation. I feel like I wanted to make a much more explicit distinction that, like, this is explicitly not for any EOA external signatures. It is like very, very explicit in terms of what it's trying to verify and the boundaries.
I want to answer that question, Francisco, and I have a stronger opinion on that. I don't think you can do it with the current ERC 1271, and here's the reason. Specifically, ERC 1271 provides a hash and a signature, and hash, we all know, is a one-way door. So there's no way without providing additional information to come back to know what user are trying to validate without a pre-agreement. Like, there needs to be some kind of implied way for the contract to have with whoever signs to know what is being hashed, right? I think maybe starting from next time when we talk with Vectorize and maybe you in the room, we should discuss how can we maybe create a new standard to make it more visible for you what user is being signed, and then of course they'll validate the hash and the results. And only in that way, the contract will be able to load the logic they need to determine the logic of how to validate them based on what they are trying to sign. And it seems to me right now, either it would be very hard, or there has to be a circumvent alternative function that needs to be called first to provide those information, and then call is valid here. So I wouldn't be surprised if some other contracts, some other function has token ID or has domain separators being verbatim plain text, and then inside of that function, it can call the is valid signature of 1271. But without that, you can't get the content of what's being hashed back from what user provides. So when the hash structure can be implied, then we can agree, right? Like, for example, like the only owner who can be recovered from ECDSA in the reference implementation, that can be implied, but a lot of things cannot be implied. And that would be my stronger argument. It is not very doable without any way to specify what's being signed.
I don't really see the point. I feel like neither 1271 nor 6066 depend on understanding what's inside the hash. And that, like, the token ID can be encoded in the signature, quote unquote signature, which is all that you need, right?
You mean
Yes.
the hash?
Sorry, what?
You mean encoded in the hash or encoded in the 65 character bytes of signature?
Oh no, you just you put it in the quote unquote signature, but you concatenate it at the end. So it's like you're adding a parameter implicitly that the NFT contract knows about, but the consumer of the 1271 API doesn't know about.
Well, the reference implementation says signature has to be 65 bytes.
1271. Oh, the
Yeah.
reference implementation is not the spec.
Okay, I think one issue with this is like, again, like you can just put stuff up there because it's Spice memory. It can be infinitely long as long as the gas doesn't blow up. But like, yeah, there still needs to be an agreement of what it's going to be. And if it's
No.
different for every single NFT, then it's or every single contract, then it's kind of not very clear, I think.
No, definitely not. So it's by design. The signature is opaque. It can be any length, any size. There can be anything in it. It doesn't need to be ECDSA, and consumers of this signature shouldn't inspect it. The only one that is allowed to inspect it, decode it, and who has any knowledge of what is in it is the account itself. And in the case of NFTs, it would be the NFT contract, but to everyone else, it's opaque. And
Yeah,
this is
I
what
agree.
allows
I withdraw my
the
other.
trick.
You're right. I was wrong about that. It's not spec. It's
You're right.
64 bytes.
I read 1271 just now. You're right. You didn't specify the length. You won. It's it's like, okay, this human written contract happened to be opaque. Did you mention it's intentionally opaque?
Yes. So we're talking about the 1271 signature, right?
Yes, you didn't mention it's opaque, but yeah, now that you say that, there's also no non-opaque specification. So yes, you can do that.
So it is opaque because could be an RSA signature, right? Or it could be an array of multiple signatures for multi-sig. Or like this 6492 one that Vectrai shared, or the one that we discussed earlier. So it allows a bunch of tricks like this. There are some issues though, because like some of the APIs, like the RPC APIs, they're specified to return 65 bytes. That's where the issue lies. But that's fixable because it's off-chain infrastructure. And I don't think it's specified like that. I don't think anyone is enforcing it. So that's why things haven't broken yet.
Well, yeah, it seems like the signature is opaque, and then you can include it in the signature. Whether I like that the payload being appended into the signature is a good idea or not, I reserve my social opinion. But yeah, as a standard, it can be interpreted that way, and people can actually do the magic like that.
This is also.
Yeah, we need to have
you
a
don't need
way
to provide any
to specify
signature.
the schema, though.
It's possible that there's no signature at all. It's possible that the hash is just approved by some other unspecified mechanism whatsoever. I mean, the 1271 allows that as well.
Yeah. Or this 1271 can just return true without anything.
Yes. But I think it's also about intent. Like, what is it, or when developers are writing stuff, like, what is the standard, or what is the interpreted intention of the standard?
Yeah, that's up to the implementation, the adopters to decide. And as author, we can argue however it works all we want, and then everyone who adopts it has the real power. So Vectorize here.
Examples like
is having a huge
ERC404,
power.
the ERC404 thing. Like, I personally, I don't know what I think about it, but yeah, it's just like a weird way of fusing two standards in a very weird. I don't know. It's just very, yeah.
Yeah. By the way, it's not a real number. So
I know.
Here we call them Panda 404, but yeah. Cool. Well, this is great. I think we're over time. Thanks everyone for being here. Thanks Vectorize to bring this up, and thank Jack for presenting 6066. Redek, Thank you so much to be here. Look forward to yours. And then Francisco and William, I think we won't have this high quality discussion without like adopted authors. Like we should have a special term called adopted authors, like authors who have ERC widely adopted, being here and give your opinion. So thank you very much. As always, this is meant for ERC builders to come together. Look forward for more conversation. And if you want to bring up some topic, please let me know. We run another time 2 weeks after this one and in a different time zone friendly. So thank you for being here today, everyone. This is AllERCDevs Season 2, Episode 4.
Thanks.
Thank you. Bye.
Thanks. Victor, what's the best approach to give you some input?